Right triangle trigonometry. So we have some inverses, trigonometry functions, and here are 3 important ones right here. And let me explain to you right quick. So if I have sine of alpha equals x, and I am wanting to know what alpha is, then I need to take the inverse of both sides of sine in order to get alpha by itself. And when I do that, I get this. Alpha is equal to sine inverse of x. And if you go back to the inverse rules, it literally states that in the log, go to the logarithm rules in natural logs, it tells you that I have log base b of x is equal to y, then its inverse would be b raised to y equal to x, okay? So this just goes back to those definitions. This is a basic algebra definition. So cosine, if you notice here, inverse of x equals to alpha will also give us cosine alpha equal to x. Sine falls between negative 90 degrees, or the angle falls between negative 90 degrees and 90 degrees, where cosine falls between 0 degrees and 180 degrees, and tangent falls between negative 90 and 90. Okay, so the reason why tangent falls between the same as the sine is because we can't have 0 in the denominator. So this goes back to the previous section that I had spoken about when we were solving for tangent. Here is trigonometry functions of an acute right triangle. So I would know these, definitely memorize these. Down here, you'll notice there is a right triangle diagram. It's showing you that we have a 90-degree angle on a right triangle right here. You see it? And then this is the longest side, so it's called hypotenuse. And then this side here, which we call y, is opposite, and this side here we call x is adjacent. It's also known as r for the hypotenuse, y for opposite, x for adjacent. You see this here, and it's showing you an angle here. So on example 1, let's solve for it. It says, what is tangent of the square root of 3? Well, you're given this graph. Well, actually, it's not asking what tangent is. It's wanting to know the actual angle, right? This theta. So to find that, you're giving this graph, but it was pulled from the unit circle. And it says here, tangent at alpha. And we come here and look down and find where it is equal to the square root of 3. And we notice that is at 60 degrees. Now, mathematically, we can solve this to find it by using the unit circle to find out, because remember, tangent is sine over cosine. And if we go to find 60 degrees, we can find the value for sine and the value for cosine, reduce it down, and we get square root of 3. And that's how you can check your work to make sure you're right. Example 2 says find the exact value in radians of the expression cosine inverse of 1. So you could draw a picture or a graph to help you. This one up here to help you. What we notice is cosine. If I was to type cosine of 1 in my calculator, I'm going to get some decimal looking number. But you actually have a button in your calculator. You can shift it over to the inverse, and it will give you as the answer a 0. But we can also come up here and find our values and then do basic math and calculate that as well. Example 3, we are going to type it in our calculator exactly as we see. So if you take tangent of inverse, so again, just use the shift button, tangent inverse, 4.76, close the parenthesis, and let's go out 4 decimal places. We get 78.1356 degrees. Now that's saying if the direction says round to the nearest tenths, remember that's just 1 decimal place. We look behind it to determine if it rounds up or down. So just make sure and read the instructions on if it wants you to round to what decimal place. So this is degrees because, like the definition said at the beginning, that our angle is equal to the inverse of either sine, cosine, or tangent of some point we're calling x, okay? So we're going to use a calculator on to find the angle of alpha that satisfies this. Well, in order to find alpha on the sine of alpha is equal to 0.640, we need to take the inverse, sine inverse on both sides. So I got sine inverse of that 0.6404. And on your calculator, again, you're going to hit the shift button, 0.6404, close parentheses. I'm going to round to the nearest tenth. So I get 39.8 degrees. And don't forget, it is approximate. It's not exact. If you notice, I got approximately signs here. So number 5 says, let's find all the exact values of all 6 trigonometric functions for the angles in this right triangle. So we are giving what x and y is. We don't know what the hypotenuse is because remember that's the longest side and there's no value there. So we're going to have to do a little bit of work. So if it helps you, I would go ahead and label this. Get my, there we go. I got x and y. So we got to find out what r is. R is the square root of x squared plus y squared. So my x is 7, my y is 3. 7 squared is 49 plus 3 squared is 9. 49 plus 9 is 58. So I have the square root of 58 and nothing factors out. So we're going to leave r in exact form. You do not want to round your answer until you're completely done. And that's only if they ask you to round it. Right now, they're asking for exact values, so there's no rounding going on. So now I know what r is, I know what x and y is. So I can solve for sine of this alpha. Remember, it's y over r, so y is 3 and r is the square root of 58. And in math, we can't have the root in the denominator, so we're going to have to multiply by its conjugate. And in this case here, the conjugate is going to be square root of 58. Okay. So when I multiply the square root times the square root, that means I got that squared. I'm going to do extra notation here. That means I got the square root of 58 squared all over 3 times the square root of 58. All right, that square root reduces and leaves me with the radicand. So now I have an answer of 58. So I have 3 square root of 58 over 58. Okay, so that is my sine. Now let's find, you can go ahead and do the secant if you want to right now, or the cosecant, because we know it's the reciprocal of sine. Of course, in the homework, it might not ask you in that order, but if you already have it on your paper, that's all right. I know that I'm going to write the reciprocal of sine here. And what happens, it gives me the root in the denominator, so we're going to do extra math. We're going to multiply square root of 58 top and bottom to undo, to take away from the root. So now I have 58 square root of 58 all over 3 times 58. And what happens? My 58's reduce. Yay. So let's reduce my 58s. And now I have square root of 58 over 3. My pen's not wanting to work right. Okay, let me clean this up just a little bit. All right, so now my answer is square root of 58 over 3. Now let's find cosine of alpha? Well, we know cosine is x over r, so x is 7, r is the square root of 58, and we can't have the root in the denominator, so I'm going to multiply by the square root of 58. My mouse is acting funny. This is going to equal 7 times the square root of 58 all over 58. So I know what cosine is. I can find out what secant is by flipping cosine, reciprocal of it. So I got 58 over 7 square root of 58. And we got to multiply by the square root of 58, right? Because we can't have the root in the denominator. And square root squared gives me the radicand. So I have 7 times that 58. And on top, I have 58 times the square root of 58. If you notice, these 58s reduce. And now I have square root of 58 sevenths. And some of you are going to see a pattern and you're not going to have to do all this extra work. That's okay. Now, tangent is going to be the easiest one, right? Tangent is is y over x. So y is 3 and x is 7. So there we go. 3/7 is tangent. Cotangent is the reciprocal of tangent. So it's going to be 7/3. And we're done. We've answered all 6 functions, yes, angles, function angles. I'll say it right. So let's talk about application problems. We're going to dig a little deeper now. So we're going to solve the right triangle with specific points given to us. We have B is equal to 1.79, C is equal to 4.32, and we're going to find alpha of A, or it says find alpha using cosine functions, or beta using sine functions. So that's a notation. And we want to find A, alpha, and beta. That's what you're asked for. You're giving, and if you notice on this diagram here, we were giving different points. Here, I was trying to find without having to draw because I'm not real great at drawing straight lines. So what happens? My B here is actually going to be the 1.79, and my C here is actually the 4.32. And remember, C is going to be my hypotenuse, right? And then B right here, in this case here, is my adjacent, and then A is my opposite. Just be careful on the notation because they flip the B and A a lot in this section, and just be consistent on your diagram, and this will help you because the picture will help you get it right. All right, so in order to solve for the missing part, we're missing A, right? We can use the Pythagorean theorem. We can use the theorem of A squared equals, well, before I go to that point, some of you might be like, well, how do I know what A squared equals? Because it's always equal to C. So let's set it up and let's do that step. A squared plus B squared equals C squared. In order to get A by myself, I'm going to subtract the B squared from both sides. So that went away and left me with A squared is equal to C squared minus B squared. All right, now I know what C is and I know what B is, and I can plug in my points. My C is 4.32 squared plus my, oh, be careful. I was going to write plus because I'm so used to this formula being plus. We're going to minus, oops, my mouse is not acting right today. Sorry, guys. Please bear with me to figure out what's going on. Okay, minus the 1.79 squared. Sorry about that. I have to get a new pen. All right, so now what I'm going to do is I'm going to go ahead and take that 4.32 square it, subtract it from 1.79 squared, and I get 15.4582. That's a squared, but it asks for a. So in order to find a, I have to take the square root of a squared, because square root squared reduces itself to 1 and leaves me with a. That's what I want. But what I do to one side, I have to do to the other. So let's do that. And be sure and read the directions. It may ask you to round to a specific point. We're going to round to the nearest tenths on this one. So now I have a is equal to, and I take the square root of my answer, and it gives me 3.93. So that's what a is. And it's approximately, again, because we had to round. So let's not forget that here. All right, now let's go find alpha. So at the top, it said here that we can use a cosine if we're looking for alpha and sine if we're looking for beta. So if you notice, we have alpha is next, so that's cosine. And I want to find cosine. Well, I know in order to find cosine, well, let's just one more step. I'm going to write a here. Yeah, let's leave it as alpha. I'm getting ahead of myself, guys. All right. So we know cosine is adjacent over hypotenuse, right? In order to find alpha, we had to take the inverse of the cosine. And we know what adjacent is. Adjacent is 1.79 and the hypotenuse is 4.32. So I'm going to plug it in my calculator and use my chef's cosine inverse. 1.79 divided by 4.32, close parenthesis, and let's go to the nearest tenths, which is, or not tenths, excuse me, I said tenths would go, I meant hundreds, guys. Let's go to the nearest tenths on this one, which would be, that would be the nearest tenths, and this would be the nearest hundreds. So just be sure and read, because I found one place it wanted the tenths, the next it wanted the hundreds. This is an actual angle, so it gets a degree on it. So I got 65.52 degrees, and again, rounded to the nearest hundreds. All right, now we want to find sine. Well, what I can do is notice that this is a right triangle, and I know that if I add alpha plus beta, it has to equal the 90-degree angle. Well, since I know what alpha is, I could just solve for beta by subtracting alpha from this formula, and let's plug in 90 degrees minus my alpha, which is 65.52 degrees. So let's say 90 minus 65.52 gives me 24.48 degrees. All right, very good. Moving on to our next one. Example 7. Example 7 says solve the right triangle with the given side and the angle. So your given angle 18 degrees. Now again, I found a picture that was easier than to draw, but if you notice, the angles are not the same. So I do apologize. Let's go ahead and label and change them out right quick. We know that we have this here as my alpha. Let's make sure my pen's working. And we said it was 18 degrees. And then this here is my C, which is 20. Oh, don't know why. I was looking because the 80 degrees here, yeah. Well, what we know is 90 degrees is right here, right? And then the other two corners together gives me my other sides. So I can figure this one up right quick. I know that alpha plus beta equals 90 degrees. We know what alpha is, so beta is going to be 90 degrees minus that alpha, which is 18 degrees, which gives me 72 degrees. And I was going to give you all that answer. That's what I was looking at. Well, wait a minute, but then I realized I need to show you the math. So this becomes 72 degrees. All right, so we're good. Now we don't know what A and B is, but we know it's C and we know the angles. So let's get started solving these. So I know that sine of alpha is going to be the opposite over hypotenuse. I know the cosine of alpha is adjacent over hypotenuse. And I know that tangent of alpha is going to be opposite over adjacent. All right. So now let's solve for the sine. Well, we know alpha is 18 degrees, right? We don't know what A is, but we do know what hypotenuse is. Hypotenuse is 20, right? Now let's solve for A. In order to solve for A, we need it by itself. And if you notice, it's involved in a fraction, and it is in the numerator, so it's going to make it a little bit easier. All I got to do is multiply by the denominator, right? It goes to 1. Then that means I got to multiply this other side by it. So now I have A is equal to my 20 times sine of 18 degrees. And I'm going to type it in my calculator. So I get 20 times sine 18 degrees. Make sure you're in degrees mode, close your parentheses. And let's round to the nearest tenths. So I get 6.2 for my A. We're good. So we know what A is. Moving on. Now we're going to solve for B because we don't know what B is, right? So B or beta, we already found beta, but we're going to, well, let me take this back. We found beta, but now we need to find B, and beta is involved with B. And anytime you're in question, just come and look at your picture. Look at the setup. It'll be a little bit neater than this one, but you'll see how B is going to be across from beta, right? Okay, it's not very good drawing, but all right, we will have to get a new pen. Okay, so please bear with me, thank you. So now what I'm going to do is I'm going to take sine of beta equal to B over the hypotenuse, right? But we know what the, because it's opposite over hypotenuse. But we know what this is. We know what the beta is because we just found it right here, 72 degrees. We don't know what B is, but we do know what the hypotenuse is, and it's 20. And again, B is involved in a fraction. To undo the fraction, we need to multiply by the denominator, and which works out great because it leaves B by itself. So now I have B is equal to 20 sine of 72 degrees. And I'm going to type it in my calculator, 20 sine 72, close parentheses. And I'm going to round to, if you round to the nearest tenths, we're going to get a decimal of 0. Just make sure and see what the software asks for, or your homework, whatever you're working in. And that answers those questions that found all the missing pieces or the unknown. All right, moving on. Let's do this next one. It says this photograph is taken of a building. Okay, so the photograph is made when the angle of the elevation of the sun is 26 degrees. The shadow is determined to be 80 feet long. How tall is the building? Okay, if you'll notice, again, I just pulled a picture. I got to learn how to draw straight lines, and that's something I'm going to work on. So this would be 26 degrees here, and this one would be the 80 feet, okay? So now we are looking for the approximate height of the building in feet tall, and we're looking for Y. So what I know is I can use tangent here. So find the height of the building since the angle of the elevation of the sun is 26 and the length of the shadow is 80 feet. You can draw the picture. Again, let Y represent the height of the building. Since you have the side opposite and the side adjacent to the angle, get it? We have those two. Then we can use the tangent. Because remember, tangent is opposite over adjacent. So we know it's 26 degrees and is equal to Y. We're solving for Y over 80. Well, to solve for Y, I know that I'm going to multiply both sides by 80 because it's in the denominator. So Y is equal to 80 tangent 26 degrees. And let's plug that in our calculator. And I get 39 feet, 0.0 rounded to the nearest tenths. I'm just going to go ahead and say 39 feet tall. So it's approximately, it's not exact because we do come up with a decimal place. All right, moving on. So from the top of a lighthouse, 52 feet high, the angle of depression to a small boat is 45.2657 degrees. How far from the foot of the lighthouse is the boat? So we want to determine how far away from the foot of the lighthouse to the boat. Okay, so we have this right here. You see the picture. So the first thing I'm going to do is let D be the distance from the foot of the lighthouse to the boat. Also let X, let's write it down. Let's let D be the distance from lighthouse to the boat. All right, I'm going to let X be the depression to the small. Okay, so we're going to let A be the depression to a small boat. Okay, let's just write it here so we don't have to write extra. Okay, so the measure of the angle is 45.265 degrees. Note we got that. So relative to the angle X, 52 is the opposite side. So right here, you see this would be opposite, which makes sense because it's Y, right? To find the distance D, the trigonometric function that relates to the adjacent side and the opposite side, note that the tangent function relates to adjacent side and opposite, right? So if I use my tangent, I know that I got tangent of 45.2657 degrees, and this is all going to equal my opposite over adjacent, and my opposite is 52, and my adjacent is going to be D. It's going to be the distance from the lighthouse to the boat. Makes sense. Now we're wanting to solve for D, and D is in the fraction. And if I multiply by the denominator, well, D is in the denominator. So we're going to have to do a little bit more work. So let's go ahead and do it. So now I have D tangent of 45.2657 degrees is equal to 52. But I need D by itself. So since it's involved in multiplication here, I'm going to divide both sides by this. So now I have D is approximately equal to, and I'm going to type this in my calculator. And just be careful. I got 52 divides my tangent. And you got to make sure that the tangent's in the denominator, 45.2657. Make sure you're in degrees mode. And I'm going to round to the nearest whole number here. So before I do it, I want you to see what I get. I get this. So I want to round to the nearest whole number because we are talking about approximate feet away from something. So it's going to be approximately 52 feet away. Okay. Let's see if we have one more. We do, yay. Let's do one more and then we're done with this section. All right. This one here says, let me put my mouse in here. It says that the angle of the elevation of a pedestrian crosswalk over a busy highway is 8.33 degrees, as shown in the diagram here. In the distance between the ends of the crosswalk measured on the ground is 352 feet. So we see it right here. That's going to be my X, right? Then what is the height, H, of the crosswalk? We got two right triangles going on right here, right? If you notice, see if my pen don't cooperate with me. If you notice, we have this right triangle, and then come on now, this right triangle. Okay, so let's solve for this. We're going to let points A and C represent the ends of the crosswalk where crosswalk meet. Okay, so we got A and C. And the ground, meet the ground. Let B be the center of the crosswalk. So B be the center. Of course, we're calling it X. Or well, the whole thing down here is X. Okay, and D be the point where B meets. That's right. Meets the ground. Okay, so I'm gonna put B at the top. I'm gonna put D right here. All right. And it's the midpoint of AC. So we have a triangle. I have a triangle ABD, right? And then we have a triangle of CBD. So I just showed y'all we had two right triangles are congruent. The length of AC, well, we know the total length of AC, that was given to us. That was my X, right? 352 feet. All right. Then the length of AD is half of that, which makes sense, right? Because from here to D is half of 352. So AD, so I'm going to divide 352 by 2 because it's half. It's 176. Then that tells me CD is this 176. Okay, that makes sense. All right, so the length of AD, okay, we got that. Now angle A inside AD is known in the right triangle of ABD. Use the trigonometric ratio for angle A to find the height H when that if alpha is an acute angle of the right triangle, then the sine, cosine, and tangent ratios of alpha are also given, okay? So I'm going to use tangent to solve for this. So we have tangent of A is equal to BD over AD. Well, I know what A is. It was given 8.33 degrees. We don't know what BD is, but BD, right? You see this is actually my height. So I'm going to call it H. I do know what AD is. We just found that is 176. So let's solve for H. By undoing the fraction, we're going to multiply both sides by 176. So H is going to equal 176 tangent 8.3 degrees. Let's type it in our calculator. And okay. I'm going to round to the nearest tenth. It's 25.8 degrees, or 25.8 feet in height. And that is solving for the height of the center of the crosswalk.